Hello everyone, I am Professor Keka Hazra. Welcome to my today's lecture. Topic is representation of Boolean function, and in my previous lecture already I have mentioned a Boolean function, any Boolean function can be expressed in three different ways: canonical form, standard form, non-standard form. Out of these three forms, canonical form already discussed in my previous lecture. Now I will discuss on standard form and non-standard form. What is standard form of representation? In the canonical form, it is necessary, it is mandatory that the minterms or maxterms should contain all the variables of the Boolean function, either in complemented form or in non-mod form. In canonical form, already I have discussed, there are two ways: sum of minterms form, canonical SOP form, and another one is product of maxterm form, that is canonical POS form. So in the canonical form, it is very much essential that all the minterms or maxterms should have all the variables that the function contains, either in normal form or complemented form. But in standard form of representation, this restriction does not exist. There are two types of standard form: sum of products form, SOP, and product of sum form, that is POS. What is SOP? If we consider the Boolean function like this, f equal to wzx plus yz, this is an example of SOP form. But this is not canonical SOP form, canonical sum of minterms form. Why? Because in this expression we can observe, we can see that function contains how many variables? 4 variables: w, x, y and z. Function contains how many terms? 2 terms. First term is wzx. First term does not contain all 4 variables. It is missing variable y. Similarly, second term is yz, that contains 2 variables, y and z. That means it is missing the 2 variables w and x. So we cannot call this expression as sum of minterms form or canonical SOP form, but we may call it standard form, that is SOP form, sum of product form. So this is the basic difference between standard form and canonical form. What is the difference? In standard SOP form, the minterms do not contain all the variables of the function. So the expression is the standard form of the product expression. If the minterm of a particular Boolean function, particular Boolean expression contains all the variables of the function, then such expression is called canonical SOP or canonical sum of minterms form. Example of this is f equal to xy bar plus x bar y. This expression may be called canonical SOP because function contains 2 variables x and y, and both the terms containing all 2 variables x and y, either in normal form or complemented form. Similarly, another form of standard representation is POS. Here we take the example f equal to 2 maxterms are there, w plus z plus x dot y plus z plus w. This is an example of the product of sum form. Here the function contains 2 maxterms, and both the maxterms do not contain all the variables of the function. First of all, we will see function contains how many variables? 4, w, x, y and z. Function contains how many maxterms? 2 maxterms. First maxterm contains 3 variables w, z and x. It is missing variable y. Similarly, second maxterm also contains 3 variables y, z and w. That means it is missing variable x. So we cannot call this expression product of max term, canonical POS, but we may call it standard POS. So this is the basic difference between standard form of representation and canonical form of representation. And lastly, non-standard form. Out of three representations of Boolean function, canonical form of representation, standard form of representation, and third one is non-standard form of representations. So now I am discussing what is non-standard form of representation. Non-standard form of Boolean expression are those expressions which are neither in SOP form nor in POS form or nor in any canonical form. We can take this example: f equal to wy plus z plus xw ANDed with xy plus xyz. This is an example of non-standard form of representation. But if we want, then such type of expression, non-standard form of representation, can be converted into either canonical form or standard. Example, f equal to, we are taking another example like this: f equal to ab plus cd ANDed with a bar b bar plus c bar d bar. This expression is neither in SOP nor in POS, but we may convert it to a standard form by using the distributive law. So f equal to, we are getting, if we logically multiply ab a bar b bar plus a bar b bar cd plus ad c bar d bar plus cd c bar d bar. So first term and last term goes to 0. So next step, f equal to, only we are getting two terms, a bar b bar cd plus ab c bar d bar. So this is example of standard form. So if it is required, then we may convert non-standard form of representation of Boolean function into standard, either standard form or canonical form of representations. So here is the end